Having struggles in your 3D modeling? No worries, I'm here to help you. And welcome to Stephen's CAD Corner. But first of all, what is CAD? CAD stands for Computer Aided Design. It is a technology used by engineers, architects, and designers to create, modify, analyze, and optimize their designs before it is taken into the real world. But what software are we going to use? There's a ton of available software in the internet for us to use. But in our case, we will use SOLIDWORKS. SOLIDWORKS is a CAD software used by engineers, architects, and professionals across various industries. It helps in creating 3D models and assemblies, transforming our ideas into tangible products. So let's start modeling using SOLIDWORKS. So now we will start drawing a design. This camera will help us here, which is shown on my right, but later on it will be shown on my left side. So you can see the mouse movement, the clicking, the dragging, and the inputs I'll be going to use with my keyboard. So let's go with this design. So this is the design that we are going to do. It's a 4-cylinder engine assembly, and it is composed of multiple parts. So as you can see, we have 6 parts to be done in this assembly. First is the piston, second is the piston ring, and the third one is the crankshaft, and the fourth one is the connecting rod, and the fifth one is the connecting rod cap, then the sixth one is the piston pin. So we will create these parts individually, then creating a assembly later on, and it should look like this. So let's proceed on SOLIDWORKS. So this is the SOLIDWORKS interface. As we are making a 3D part, or we will click this new, or simply clicking on your keyboard Ctrl N. Then there are 3 options: part, assembly, and drawing. And as we are creating a part of this assembly, so let's choose this option part. Then click OK. So now this is the interface of SOLIDWORKS. Here above, you can see the navigation bar of SOLIDWORKS. So features, sketch, these are the toolbox: sketch, markup, evaluate. So usually we'll be using this sketch and features as we are creating this part. So here on the left side of the interface is the navigation tree, and this is where you can see all your sketches, your features to be done as you create this drawing. So let's start with creating this piston. So now we'll be creating this first part, which is a piston. So first we need to create a sketch for this one, since it's round, and I think it's best to draw this on the top plane. So let's choose top plane. Then we will need to create a sketch. So we need to create this sketch geometries in order as to create a sketch for this piston. So there are 2 ways: by clicking here on the top toolbar, or by holding right click, and you will have 4 options: circle, rectangle, line, and smart dimension. So for this one, we need to create a circle. Then the dimension for this one is 85 millimeters as shown in the figure. So it's shown here. And as you can see that my entity is automatically have smart dimension, you can enter options to have this feature. Go to sketch, then enable on-screen numeric input on entity creation, then check in discrete dimension only when value is entered. So it might be helpful for you or not, but it's your preference. So we need to create a feature for this one. So go to feature, extrude base. Then we need to extrude this by 90 millimeters. Either drag it here or manually input the values. 90 millimeters. There you go. Now it's by clicking check, we have this feature. Now we need to make this hollow. Since this sketch is, as you can see in here in section view, the sketch is hollow. So we can do this by creating sketch, either choosing this face below, or choosing the same plane where you created the circle. So the dimension here should be 76. So I need to create 76 and go to features, extrude cut. So extrude cut is opposite of extrude boss base. Extrude cut is used to cut some parts of your solid body or the part you have created. So the height should be 85 millimeters. So click check. Now you can see that our part is hollow. So to make the view of this part, right, after you making this dragging or navigating the orientation of your part, the navigating of your orientation of the part is done by clicking the mouse wheel, then dragging it. So you can navigate the view of your part. So to fix it to isometric, either click Ctrl+7 on your keyboard or space, then click in this. There, you can fix the view of your part. Then we need to create this texture on this side. So as you all know, we can do it by extrude cut. So sketch, choose this top surface, then the diameter of this one is 79 mm. So go to features, then click extrude cut. And as you can see, the cutting of this one have an offset of 7.3, or the thickness of this texture. So we need to offset this extrude cut. We can do it by going this, clicking this, the start condition from, then offset to the height of the thickness of the texture, which is 7.3. So flip offset, then the thickness of the cut is 4.3. Then click this flip side to cut, so it will cut outwards, not inwards. So by clicking check, you can see that we have this feature. So there are another way of doing this part. It's by using revolve base, so you won't be needed to do this one by one, this cutting. So as we can say, less features is better, but we can I did this so we can have more experience on navigating what SolidWorks can offer us. So let's proceed. So as we are needing three of these features, we can use this linear pattern. Click linear pattern, then click this cut extrude, then click linear pattern. So we'll be needing this 0, and we need to click to what direction it should be going. So go in this face there. So the dimension for this one is 7.3 plus the dimension of the cutting. So 7.3 plus 4.3 plus, so it's 11.6. Then click check. Now we have this, we have completed this texture. So next, we should do this hole of 33.8 millimeters. So go to sketch, sketch on the right or front plane. In my case, I'll be using front plane. Then create a sketch of this circle, having a dimension of 33.8 millimeters. Then we should define the circle, the location of the circle. So click the center and this lower part. Then the dimension of this one is 27. So it's the spacing from the bottom to the center of the circle. Then, since it's still underdefined, we need to create a relation. So click the center of the circle and the center of this origin, then click vertical. So when your sketch outline is black, it means you are fully defined, or the sketch is fully defined. So click features, extruded cut. Then in this drop down menu, we should click through all both, so we can extrude cut both sides. Then click check. Now we have generated this hole in our sketch. Now there's more. We'll be needing to extrude cut also this feature. So click to sketch, sketch on the right plane perpendicular to the plane where we created the hole. Then we need to sketch this. So roughly sketch this one. There you go. So let's define dimension for this. It's 50. And then to make it centered, click the center of this line and the origin. Then click coincide. There. Then define this, the height, which is 12. Then to make this one related to this one, click this line and this, then hold control, then click the other line, then click add relation, which is equal. Oh, wait, we need to coincide this and this one, make coincide. So there. Now we have to create this arc. So we need to click this one, select the arc type. So I'll be selecting this 3-point arc. So 1, 2. Then enter the radius of this arc, which is 10. So it's 40 rather. It's 40. So click features, extrude cut, then extrude through all both. So now it's the cut should be generated. So we'll be applying this fillet here in our feature. So click fillet, then it should be 10 mm. Then click those. Those lines where you needed to create this fillet. So you click check. There you go. We have this rounded edge. Finally, as you can see in this drawing, we need to create a tube that is not meeting at the center. So it's a bit challenging to do this in this way, but still we'll go through and do it. Then we need to go to sketch, then select the plane where you also created the holes of this one. Then create a circle. So to snap it to the center of this existing circle, we need to drag along the edge, then click the center. So the dimension for this one should be it's 12 from the bottom to this edge is 12 millimeters. So we need to copy this, delete this circle, delete this. We can copy this by clicking to the circle, then convert entities. So the dimension for this thickness should be 5. So as we create the circle, we need to enter 45 millimeters. So the offset from this to this should be at least more than 45 millimeters. Yeah. Then we need to extrude this feature. Then click up to next. Then we need to offset it by half of this dimension. So SolidWorks can do math. So we can enter 38 divided by 2. So yeah. Then click check. Now we have this feature. So to iterate it on the other side of this one, we can use mirror. Select mirror. Then select the plane you want to mirror. In our case, it's the front plane. Then click check. There you go. Now we have this features. So lastly, we need to create the dome of this one, which is this arc. So to create that, click insert, features, then click dome. Then select the face you want to create the dome. And the size is 5 millimeters. There. We now completed the piston drawing. So you can apply the material specified for this one. So there's a lot of options here. So as for my part, I will just edit the appearance of this part. So let's go to steel, then go to brush steel. Again, go to this, select the geometry, and brush steel. Then click check. So when you open this field with graphics, we'll be having this appearance of our part. So click save, Ctrl S, go to our documents, and create the folder for this one. Engine for cylinder. Engine. Then name it piston. Then save. So that's all for the first part of this assembly, which is the piston. So now we are done creating the piston. We will now proceed to this part number 2, which is the piston ring. So as you can see, it's easy to create. So let's click new part. Okay. Then we need to create a circle for this one. So click sketch, choose top plane, then create 2 circles. Its dimensions are 79 and 85. Then click features, then extrude both base. Then automatically the SolidWorks software will select this part only to extrude. Then the height should be 4.3. Yeah. Click OK. So same as the other parts that have created, same as the piston, we can edit the appearance. So this looks like an iron. Then just cast iron. Then click check. Now our part is on. So save, Control S. Then name it Piston Ring. Then click save. Now this part has been saved. Now proceed creating this crankshaft. So now we have to create this crankshaft. So to create this, we need to create a new part. You can do it by doing Control N, then clicking this part. Then create a sketch of this part. So go to sketch. Then for me, it's best to draw it in the front plane. Then we need to draw this one. First, we have to create construction lines for this. So midpoint. There. Then create the circle or this arc, which have a 36 radius, but since we are inputting values in diameters, so we should multiply it by 2. We can create this center point arc and having a radius of center point arc. And we will define the values later. So create dimension for this, and this should be 44. Then connect this to by the tangent. Make it tangent to the circle. You know it's tangent when you snap relations or appear relations there, having that symbol. So we now define this, our sketch should be 80. Then the angle of this is 33. Then these two lines should be equal. So click first line, then the other line, then create equal. Then trim entities of this two sides of the circle or the quadrant of the circle. Then we have this part. Now we can extrude both base this one with a dimension of 15 millimeters. Now we should create these two circles, as you can see in this assembly. So we should create first this 72 millimeter circle. Then extrude both base. The width is 38. Check. Then do the other circle on the other side. So this circle is concentric with this arc. So we can find the center point when we drag our cursor near to this arc. Then it should show this center point. then enter the value of 54, then extrude both base, this, and set the dimension to 46 millimeters. Now we have this set of this crankshaft. So since this part is identical to this one, we can use the mirror function or mirror feature of SolidWorks. So first create a plane so that our part that will be mirrored is centered to this circle. Click check, then click mirror, then select features to mirror. So there, click check. Now we have this features that are mirrored. So hide this plane. There you go. Now we can also mirror this one, but the problem for this one is it should be inverted. So to do this, follow these steps that I am going to do, since it will be hard to do this, to rotate this one. So let's start by creating a plane or a mirror plane for this sketch or for this part. Then use the mirror function. Then select the mirror plane to this plane. Then choose bodies to mirror. Then uncheck this merge solid. So later on, we can rotate that part that we have mirrored, because when merge solids is checked, it will merge to this solid body. So uncheck this, then select this one, then click check. Now we have mirrored that part. So to rotate it, go to insert, features, then move and copy. So select the bodies that you want to rotate. We should rotate it by 180 degrees rather. It can be along X or the Z axis, 180 degrees. There you go. Now we have rotated this part of the crankshaft. Now we again do the mirror this body. So create a plane for this one. So select these two faces. So that will be centered to the circle. Then use that plane as the mirror plane. Then select bodies to mirror. As we click check, you can see that we have completed this part of the crankshaft. So hide this plane. Then we need to merge this so that we don't have 4 bodies here. So it can be combined as one solid bodies. You can go to insert, features, then combine. Now click the bodies that you want to combine, then make sure it's add, then click check. Now you can see it's defined as a one solid body. Now we need to create this shaft and this nut or the holding part of this crankshaft. So sketch this and just this face as the sketch plane. Then draw a 32 millimeter circle. It is shown here. Then extrude both base is 1 by 80 millimeters. Then click check. And as you can see, it is chamfered by 45 degrees. So click under this drop down of fillet, we have chamfer. Then choose this edge to chamfer. Then change this diameter to 2 and make sure it's in 45 degrees. So click check. Now we have a chamfer this part. Now we can do the other side, which is shown in here. Okay, dimension. So create a sketch on this face, then enter the value of 144 millimeters for the inner, and create a construction geometry of a circle that have a diameter of 110. So check. Then we should have 8 holes of 10 millimeters circle, or having a diameter of 10 millimeters. So we can stop it here, this point, then enter 10 millimeters. Then we'll use the circular sketch pattern and put here 8. So we have 8 iterations of this sketch. Then click check. Then since it's underdefined, we can fully define it by clicking here, fully defined sketch, and calculate. There you go. Now we have this part. Then the only thing we should do is to extrude this part, or this sketch. The width of this one is 15. Click check, and now we have finished this crankshaft. The only thing that we should do is to create a fillet of this part. So there's a feature here in SolidWorks. So the radius here is 3, where you can select this. So as you select this fillet, though, it will bring out this subcontext menu. So click on all concave, so you don't have to select manually each of this edges that you want to create a fillet. So click check, and now you have fillet all of those concaves of the circle. So there you have finished your crankshaft. So the only thing to do is to edit its appearance, choose the material that you want. As for my part, I want it to be steel, and yeah, brush steel. There you go. Now we have completed the crankshaft. We need to save it. Please. So now we have done the crankshaft. Now we will start creating this fourth part of this assembly, which is a connecting rod. So to do this, press Ctrl N, then create a new part. So for this one, we should analyze first this part. As you can see, we have 2 circles. For this one, it's an arc. So we should create this first, then create this connecting part of this connecting rod. So go to sketch. I'll choose front plane to sketch this. Then create a construction line for this one. Then create this top circle having a inner diameter of 33.8 millimeters. Then another circle that have a 45 millimeter diameter. So for the bottom part, it says radius 36, meaning it's 36 times 2, because we set circles here in diameter. And for this one, it's radius 27, so we should also multiply it by 2. Now we set the distance of these 2 circles, and it should be 101.2. So there. Next, we create this line along these two circles. So press this one. So here it creates an automatic relation which is tangent. So to avoid this, just create a line here between the two. To connect these two, should click this and click this, then set a relation to coincident, same as to the bottom circle. Make coincident. Now we can mirror this via this construction line. Mirror about this one. There you go. Now we have this connecting line. Now we set the dimensions of this. The distance of this two should be 20. And the angle of this spreading should be 6 degrees. There you go. Now we extrude these two circles first. Click this, click this. It should be extruded in mid plane, and the width should be 38 millimeters. So enter 38 millimeters, then click check. Now we have this. So in order to extrude the middle part, click this drag down menu, then click sketch, then extrude both base. So click the parts that you want to extrude both base. We didn't extrude both base simultaneously, these two parts, because it has different width. So that's why we do it separately. So enter dimensions of 18 millimeters, then click check. Now we have these connections. Now we set our fillet of this. This should have a fillet of these two edges. Fillet of 22.5. There you go. So we should also fillet this too with the radius of 40. So let's go do that. Select this edge and select also the edge on the other side, then put 40 as the fillet. There you go. Now we've done this part. Now we should create this slot. So click sketch, then choose this face, sketch, then create a straight slot. Make a center point slot. Then since the dimensions here is 90, you should divide it by 2. 45. Then the radius of this should be 8. So set the dimensions there. Now it's fully defined. We can perform extruded cut. So we should cut this by 4 millimeters. There. And as you can see, the inner part should be having a fillet feature. So click fillet, then click, then set it to 1. Then after that, we can mirror it on the other side of this part. So to do that, click mirror, then select a mirror plane. In our case, it should be right plane. No, it should be front plane. Then select features to mirror. So select this feature and click check. Now we should have this feature also on the other side. Edit this feature. Then add this fillet on the other slat that is being mirrored. There you go. Both of those slats have fillet inside. Now we create this screw holes of the connecting rod. Cut this part of the half of the circle. So go to sketch, select this plane, then sketch. Now we create a convert entities for this one. Convert entities. Then create a midpoint line that runs through these two. Then trim this one, the other one. Then perform a extruded cut so that it will be through all. Cut through all. So just create a sketch on this plane or in this face. Then create the slot by this and this. We can use straight slot, but since it should be centered, you center slot. So 76 divided by 2. Then the radius is 9. So when we multiply it to 2, it's 18. Then define the sketch by defining the dimensions of this slot. There you go. Then we create this holes for the circle, which is 9 millimeters in diameter. There you go. Then we should be able to extrude both these features by 30 millimeters. Then select blind. Then reverse the direction of the blind. There you go. Now we have created this one. Then we should only need to cut this so it will be having a hole. So click this face, convert entities, then extrude cut through all. Now we have done this part. The only thing we should do is create a fillet for this arc, for this one. So fillet, select this and this side, then create a fillet of R3 millimeters in radius. Now we are done with this part. There you go. Make this in a isometric view. Then we edit the appearance. So we should be selecting brass for this one. Let's try cast brass. Click check. And now we have done this part. There you go. Let's save it and name it connecting rods. Now we will do this part, which is the connecting rod cup. So to do this, press Ctrl N, then click part, then OK. We'll do the same process on how we did this connecting rod cup. So first, let's sketch front plane, then create the inner and the outer diameter, which is 36 times 2 since it's in radius, and 27 times 2. There you go. Then create a midpoint line along these two circles. Then trim this two and this one. Then click check. Now we should be able to extrude both base this and make it mid plane, and the dimension of this one is 38 millimeters. Next, we will create the slot part of this connecting rod. So click sketch, select that face, then create a center straight slot. Set the length to 76 millimeters. Then so it should be 76 divided by 2. So 76 divided by 2. Then the radius should be 19. So we multiply it by 2. There you go. Now we define this by setting the smart dimensions. And there you have it. Now we have that part of the connecting rod. Now we should also create the holes for the screw. So it should be 9 millimeters in diameter. So extrude both base, then extrude it blind going to the opposite direction by 60 millimeters. Now we have this rough sketch of this rough part, a rough completion of this part. So still you have to do these cuts. So create a sketch. Then since we also need to cut this one, we can convert entities for this, then create the cuts. Now, so roughly sketch the area to be cut, then set dimensions. Let's first set dimensions for this, which is 27, and dimensions for this one, which is 22. Then we can mirror these entities, mirror about the plane, which is right plane. So we have 2 copies of that sketch. Now we extrude cut this sketch. Click this, click this, click this. Now through all, select through all both. There you go. Edit feature. Then select also this part to be extruded both. There you go. Now we have completed this part. Now this part needs some fixing because it doesn't have the holes that does not go through this. So create a sketch. Select that plane. Then create a circle, same dimension as this one, to that also. Check. Then perform a extruded cut. Set it to true all. Oh. There you go. So that hole should completely go through. Then set the appearance for this, and the material should be the same as the connecting rod that we've done. So it's cast brass. Check, then save this part. Now connecting rod, cap. Click save. So lastly, we should end this creating parts by creating this piston pin. So it's slightly much easier than the other parts that we've done. So let's create this. Press Ctrl N to create a new part. So for me, the best plane to create this is still in the front plane, because when we assembled it, this piston pin will face that direction, so we don't have to do rotations. But otherwise, we can still create this on the top plane if you found it more helpful to do it in the top plane. So to create this, we create a circle that has a diameter of 33.8 millimeters. Then simply extrude post base this one. We can select blind or mid plane. For this one, I select mid plane, and the dimensions or the width of this extrusion should be 82 millimeters. There you go. Then since we've have this part having a chamfer of 2 millimeters that has an angle of 45 degrees, to do that, select this drop down, then select chamfer, then click the two edges that you want to chamfer, then put 2 millimeters to check. Now you've done the piston pin. So that's all for this piston pin. Edit appearance. I'll make it same as the piston ring, which is cast iron. Select body. There you go. Click check, then save. Name it piston pin. So now we've done all the parts, we will create an assembly. So as we are done doing these parts, now we will create an assembly. So to create an assembly, simply press Ctrl plus N. Let's click on assembly, then click OK. Now we have this interface. So to insert this document, so let's go to the folder where we saved our parts. So click these parts that we have done, then insert the crankshaft first, since it's the part that we're going to fix all the other remaining parts. So there you go. Let's first edit make it float so it will move freely. Now we need to create a sketch of the spacings where the connecting rods will be connected, and an axis for this to rotate for the crankshaft to rotate. So in order to do that, let's go to sketch. Now here in this drop down menu, let's click on right plane. So as you can see, here is the origin. So we will create construction geometries for the spacings and the rotation axis of this crankshaft. So to do that, select line, select for construction, and create a middle point line. So I will start at the origin so that our model will be centered, and I will create 5 lines of construction. Don't snap your lines on unnecessary relations, and we'll create the last one here at the end. So make sure that these lines are for construction or in a construction geometry. Then select all these lines and make them equal. So now we will calculate the spacings of these lines. So let's give dimensions for this one and for this one, and to calculate it, let's just add these measurements. So 80, 38 plus 15 plus the half of this 54 millimeter circle. So 80 plus 38 plus 15 plus 23. Now we calculate the spacings for these two 54 millimeter circles. So it's 23 since it's half of the width of the 54 millimeter circle, plus the thickness of the plate, which is 15, plus 38, which is the width of the 72 millimeter circle. Then let's add another 15 and add half of the 54 millimeter circle. So it's 114. Then we'll do it twice again. So let's enter 114 and another 114. So lastly, we will need to calculate the spacing from this point up to this point, or the end line of the crankshaft. So to do that, let's enter 23, which is half of the 54 millimeter circle. Add thickness of the plate, which is 15. Then add 38, since it's the thickness of the 72 millimeter circle. And add another 15, which is the thickness of this part. So click check. So there you go. Now we have this construction geometry. Then let's define the height of this one and make it 200. So it's just for reference. So let's exit our sketch. Now we will create relations for our model. To do that, let's it's either clicking here this mate, or clicking the faces or surfaces that we will going to make. So click this line and this line, then create a relation. So for this one, let's make it concentric. So there you go. It's concentric to the axis of this line. Now we need to fix this one and this point, then make a coincident mate so that it will be fixed and not move horizontally. So there you go. Even if we spin it, it will not move. So after that, we will insert other components that we need to use. So let's select piston ring, piston pin, connecting rod, and the connecting rod cap. Let's open it. and place it just somewhere near where it should be created, like this, and like that. So first we need to assemble this piston ring and create a mate so that it will be fixed here. So to do that, click this face, add a relation, again click this face, then hold control, then click this face and add a concentric relation. So there you go, it's now concentric to each other, but it's moving vertically. So we need to mate the underside of this piston and this face of the piston ring, then create a coincident mate. So there you go, now it's fixed. So to repeat it again for this part of the piston, so right click on this piston ring, then select copy with mates. Now we click next, and now we'll click the faces where we will be inserting the relations or the mates. For this one, let's click this circle and this face. So now it's fixed on that slot, then click check, then do it again lastly for this part. Click this face and click this underside of the piston ring, then click check. So as we can see it is now assembled for the piston ring. Now the next thing that we need to assemble is this piston pin and this piston and this piston. So we can add a mate of its plane, which is front plane, and the plane of this piston pin. Hold control, then select front plane, then create coincident relation. So it's now aligned on its plane, which is the front plane. Now we'll create another mate for this two and create concentric relation. Now it is inserted on the slot of the piston. Now we need to connect this connecting rod to this. So in order to do that, we can use a mate that mates the inside part of or the plane of the piston pin, either the piston pin or the piston. So in our case, I'll select piston pin and the plane of the connecting rod, which is front plane. Now it's creating a coincident mate, and we'll create another mate for this two, which is concentric, and click check. Now it's fixed to the piston pin. Next, we'll assemble these two. So to do that, click this face and this face, then it will snap and create a coincident relation. Click check. This part and this part. Check. Then let's snap this part to the bottom side of this part. Click check. Then we'll make these two faces concentric to each other. So it will be like that. So it's now assembled. So let's exit mate and then fix our view isometric. Now we need to assemble this by putting it to this crankshaft. So to do that, we'll create an advanced mate, which is with. Now we need to mate this at the center of this part of the crankshaft. So to do that, let's create a mate, advanced mate, which is with, then select the faces where we will be fixing this part. Click that and click that. Now it is aligned centered to this crankshaft, as you can see. There. Then the next thing to do is create a standard mate for this part and this part, and make it concentric, and click check. Now as we rotate this, the piston is not fixed in a certain direction. So that's why we created this sketches. In order to do that, let's create a mate for this piston body and this line, which is concentric. So when we click check, now it will move along the axis of this line. So we need to repeat it for 3 times so that we'll have the cylinder fully assembled. Hold Control as you select the bodies that you want to mate, or simply clicking one, then copy mate. Then select all the bodies that you want to copy this piston, connecting that. So there you go, it's highlighted. Then click next. Now we repeat the relation of the wheel, which is the two faces of this plate, and now the concentric relation of this crankshaft, of the rod. Now, let's click this, then another concentric, this one. So now it's upright. Then repeat, click check, then repeat it again. Click this face, then click this, and click this line. So now it's assembled. So click check and repeat it for the last time. Click this face and this face, then click this rod, then click the line. Then you can now exit copy with mates, and now our cylinder is completely assembled. So as we turn this, it's now doing this rotation of the cylinders, which acts like a 4 cylinders of an engine. So we can hide this sketch by simply right clicking, then hide. So there you go. So we can animate how these parts are assembled. First, we need to do an exploded view before we can animate how this is assembled. So let's click exploded view, then select the parts that you want to animate first. For me, I'll select this connecting rod cap, then let's move it along the y-axis, then offset it by about 150 millimeters. Then let's click add step. So let's edit the direction. There you go. Then click done. So now it's separated to this connecting rod. Click done. Then create an explode step 2, which will select this piston pin. Then select the face or the axis where we're going to move this piston pin. Then type in around 500 millimeters. Then rotate the axis of moving, so it goes to the right side of the assembly. Now we need to move these parts. Don't forget to also select the piston rings. So let's zoom. And lastly, for this part, so we can move it along the y-axis and offset it by 300 millimeters. Then click add step. So there you go. And lastly, we'll move this connecting rods and move it around 150 along the y-axis. So add step. So let's edit that. Make it 150. And click that. So now we have exploded our assembly. So what's the benefit of this? We can go right click on this assembly, then animate collapse. So it should animate how our assembly was done. There you go. Then you can animate the collapse also, or the explode of this assembly. So there you go. We have an animation for this assembly. So let's exit. Then make sure it's in collapse mode or it's assembled. Now we will create a motion study or snapping one of this part to a motor so we can see the rotation. So to do that, let's click motion study here at the bottom. Then select this motor. Then select where you will link the motor. In our case, let's click this shaft. Then make it around 50. So we will be seeing it nicely. Then click OK. So we can edit the frames that this motion study. So in our case, let's make it 30 frames per second to animate it smoothly. So let's try. Let's render it first. There you go. Let's click play. Now it's playing smoothly. So let's play it again. Now it's moving as expected. So that's the assembly of this 4-cylinder engine. I hope you learned something from this video. If you have any questions, comment it below. And also, please do like this video, share, and also subscribe to this channel. So this is Stephen's CAD Corner. Have a great modeling journey.